This is question 11, chapter 3 in the class 12 NCERT book. We have a storage battery of EMF 8 volt, and the battery have an internal resistance, very small. The lower it's better, but this one has 0.5 ohm internal resistor, and we are charging it with a 120 volt DC supply. And I don't like 120 volt. Usually if the battery is 8 volt, we usually charge it with only a little bit higher than that, maybe like 20 volt. But it's just for the sake of problem, we have a 120 volt DC, and we have a series resistor of 15.5 ohm. What is the terminal voltage of the battery during the charging, and what is the purpose of having a series resistor in the charging circuit? So let's draw a diagram. This is our 8 volt battery. Usually you will not see this 0.5 ohm resistor outside. Both of these things are enclosed in a box, and all you see are two terminals, a terminal here and a terminal here, just outside the box. And that is what you can measure using a multimeter or a voltmeter. And then we bring a big charger at 120 volt DC supply, and we use a series resistor to charge this circuit. If we connect the whole thing in this fashion, okay, we connect a series resistor, and the one end of the resistor is connected to the battery. The negative terminal of the charging battery or charging thing is connected to the negative of this battery. Then the circuit completes and the current starts flowing in this direction, because this voltage is higher and this voltage is lower. So the current will start flowing in this direction. If for some reason this voltage 120 volt is positive and goes below 8 volt, then there will not be any current flow. In fact, if it goes a little lower than 8 volt, then the current flow direction will reverse. But it's a charger, obviously its charging voltage will be higher than 8 volt, and that's the purpose of the charger. In terms of, now what is the role of this resistor, series resistor? What does it do? Well, if what happens is, you cannot charge any battery with a very high current like 100 ampere or something. If I don't use any resistor here, the current flow will be very high. It can create a spark, it can heat it too much, it can explode. And that's why we limit the flow of this current using a series resistor. And that's why there are special chargers which make only a limited current flow to this circuit. So that is the purpose of the series resistor. If you make it very high, if the resistor is very high, then the amount of the current flow will be very small, and the charging thing will take a lot of time. Instead of 1 hour, it may take 24 hours if we reduce the resistor very much. So we want to keep a resistor with a safe value. It charges fast, but at the same time it's not so low that it creates any kind of unsafe condition like overheating or sparking. Now we want to do is calculate the current in these conditions. This is 120 volt. We use the Kirchhoff voltage law. So this 120 volt minus 8 volt, that is the net effective voltage. The voltage varies like this. We start from, let's make this one as 0 volt. Then we have 120 volt at this point. There's a voltage drop across this resistor, and then there will be certain voltage appearing here. Then there's further some more voltage drop here, and then we get 8 volt at this point, and then again 0 volt at this point. This is how the voltage is distributed. So if we apply the voltage in this loop, then we get 120 minus 8. If both were the batteries connected in series, and this positive and then negative and then positive, then these two voltages would have added. But in this condition, the positive of this battery is connected to the negative of this battery, so this 120 minus 8. And this will be equal to the drop across this resistor and the drop across this resistor. If I is the current flowing, then it's 15.5 multiplied up by I plus 0.5 multiplied by I. So 55.5 plus 0.5 is 16I is equal to 112, or I is equal to 7 ampere. So we find that there is a 7 ampere of current flowing in this circuit. Now the question is, at this point, what is the voltage? If we connect a voltmeter between this point, what is the voltage we will measure? So what's happening is, there is a current flowing from here, and this point is 0 volt. Then this point is 120 volt. The voltage drops a little more here. Then we comes here, and then the voltage drops a little more here across this to 8 volt, and then 0. The voltage at this point is slightly higher than 8 volt, because if it is not higher than 8 volt, then the current cannot flow in this direction and the battery cannot charge. But what is the voltage across this? The current 7 ampere multiplied by 0.5, or 8 volt plus 7 into 0.5, 3.5 is equal to 11.5 volt. So this is the voltage that you will measure at the terminal. Now let us say I want to make it a little more clearer. So what happens when a battery is charged or a battery is driving? Let us say when the battery completely charged. Obviously at that point we will remove the charger. But let's say we now connect for example, if you have a car, we charge, the car stops because the battery gets discharged, we use an external charger to charge it, and then we connect the circuit. So the battery starts supplying the charge. When it starts supplying the charge, the direction of the current is reversed. It is giving the charge in this direction. And let us say, for the sake of simplicity, our external resistor we are supplying is also 15.5. In this case, what happens? In this case, we have a current I. Let's remove this. Current I flowing is given by V divided by sum of these resistors, which is 15 V divided by R, which is 8 divided by 16, or 0.5 ampere. Okay, 0.5 ampere. Now, if we use a multimeter to measure the current between these two terminals, the voltage will be less than 8 volt. And the reason for this is that it is 0 here, 8 here. If the voltage at this point is not less, then the current cannot flow in this direction. So, and what is the drop here? The drop here is 0.5 ampere current multiplied by this resistor. Resistor is 0.5, so the drop will be 0.5 into 0.5 ampere, which is 0.25. Now if we measure the voltage here, it will be 8 minus 0.25, or 7.75. So this is the thing that you need to keep in mind. Let's say if you have a multimeter, you charge your car, and while it is charging, you are measuring the voltage. That voltage will be slightly higher than the voltage of the battery during the process of charging. And just after you have charged it and connected your circuit back, and you are seeing the voltage right after that, it will be somewhat less than the voltage that you observed earlier. I hope I am making it clearer using the examples and other things.